Chapter 7, Administering a Secure Network. In this chapter, we're going to be talking about a couple of different things here. We're going to list and describe functions of a network protocol, example of placing security devices, telling how security data can be analyzed, and explaining how to manage and secure these platforms. So the first thing we're going to talk about is TCP protocols, since that's the language of the internet that we use. So again, as a quick little notes, we have version 4. So we have IP version 4 and IP version 6. So what are some of the differences between them? So IP version 4 is a 32-bit address. It's made up of 4 quads. We have public and private addresses, and then IP version 6 is 128 bits. Hexadecimal. This is binary. So, again, we're talking about the layer 3, so this is logical addressing. So remember, we have also MAC, which is not part of this, but just a little side note, we have also MAC address, which is a hardware address that's every network device has. So here's the main things that you should remember. An IP address is layer 3, it's logical. So it provides networking and routing. And then we have the TCP part, which is the transmission. Basically establishes connection, ensures reliability between the two devices. So originally the TCP has its own 4-layer architect, which is the TCP model, which maps to the OSI model. And here we are, the OSI model and the TCP model. So you can see here, remember, if you're going from the top down, application is worth 3 layers, 1 to 1 and 2. So 3, 1, 1, 2. If you think about the old Chicago area code and add an extra 1 to it, that could be a way of remembering it. So we just have 3, 1, 2. In some of our basic needs. So DNS, we have SNMP, file transfers. So these are some of the things, some of the big ones that networks need to operate is DNS. Again, if you're not sure what this is, go on YouTube and look up DNS explained. It's a good video. And I'll show some examples of file transfers, and I'll show a little bit of the simple network. But this is a way for basically our IoT devices to see, can we pull information from them? So there are a couple versions of it we'll get into. So now the book is going to get into the simple network management protocol. So this is a way of we can administrate little devices, simple devices, our appliances that we have on a network. We want to monitor them, like an example, like a printer. We use this protocol to communicate with these things, to monitor them, to configure them, to alert us. So we can have an agent, it can be agentless.
Here's an example of configuring SNMP. Again, just checking the box, putting some basic information in here, picking what version you're going to use, checking the box, putting that password in there. Again, here's just a quick jump into example of network time. You just turn it on. And then this is a time server. So here in the book, let's jump into here. Sorry for jumping around. I wish I would have prefetched this, but I wasn't smart enough to do that. So here's an example of some stuff that you can get with SMP. For example, this analogy device I was just showing you. So a couple things here. Here's the link I posted in the book, but a few things I wanted to point out to you here. These are some of the basic commands like get next. The book's not really getting into, but there's also another term, traps. So traps basically, it's basically started in version 2 where we have traps. So we can say what particular information we're looking for, like we can see system uptime, other types of information that's included in this. So here, the book goes, or the site goes through all the different versions of the protocol, and here's all the wonderful RFCs. So if you wanted to go and read in detail about this protocol, here you can go. Alright, back to the slides.
So here's the main things about this, and again I'll add another couple slide or a couple of websites to this too. Is basically we have version 1, version 2. They had community strings, that's basically known as its password. They also have default community strings too, so a lot of devices have their own default. So that's where in the world of security we don't want to use 1 and 2 because they're vulnerable, because they just use common strings. Version 3 require a username and password. So that's the key, with encryption. So that, because version 1 and 2 are plain text, there is no encryption or anything like that. So again, DNS basically maps an IP to address. It's basically a database. Again, check out the DNS Explained for more details on how DNS works. So here the book is trying to show an example of the DNS. Essentially, step 1, hey, how do I get there? Checks itself, I don't know, goes to DNS server and says, hey, do I know? If it doesn't know, it's going to go check the root server and so on. Definitely do look if this looks confusing again, definitely check out the YouTube video. It will make very good sense. Here, this is true. This is very often the focus of attacks because why? It's our phone book. We know how to get places. So if we can poison the DNS, substitute our own fake IP address, again, you're going to go there. We're going to have clear text. So one of the things that we've done is we set up DNSSEC. Basically, it creates a, it's an additional resource or record header, which is used to verify the request has not been altered. So again, unless everybody on the internet's using this currently right now, it's a very small group of people using it. So you can't really take advantage of it. You can set up yourself by using an example that would be like using the DNS pilot hole like I showed you guys. Feels like weeks or months ago now. But yeah. So again, you can also do zone transfers, which is another type of attack, which basically transfers your whole database of all your entire phone book to another system. And then we have a means of transferring files. So we use FTP. Now we don't use it as much. We still use it, but now we have file transfer over HTTP. We didn't have that before. So we use FTP. The main thing about FTP, again, it's clear text. So it is unsecure, so it's not encrypted. And here's an example of using FileZilla. This is an open source, most common FTP client. Essentially here you're going to put the IP address in. Here's showing you all the commands. Here you're browsing through the directory, and then you're drag and dropping stuff over to their file. And then it gives you a queue of what is going to copy from where to where. And then here it shows you the commands that it's doing in response. Yes, it looks very complicated. It's not super complicated. It's giving you all the magic sauce behind the background that you take for granted when you use Windows copy. You see a little box showing a little piece of file, a little piece of paper flying from one end to the screen to the other end. And this shows you all of it. This is sort of like all the knobs and buttons. And we'll show a couple different things. So some of the things that we should know about FTP, we should know these two port numbers. FTP 21 for the control channel, 20 for data. Most people just know 21. You should know both. So there is active and passive, but I don't think most people would even know what that is. And again, most people are not even using these services anymore. So we use file transfer protocol. This is, again, vulnerable because it's not encrypted. So it can be, in the middle. So then we have secure FTP, which basically adds encryption over it. And securing our email protocol, we have SMIME, which is a secure multi-purpose internet mail extension. So some of the things you can't do, you can't use this through the web browser. So instead you'd have to use HTTPS. So here's the other downside with SMIME is you can't inspect the email for malware or anything like that. Well, it would make sense. It's encrypted end to end. And then you'd have to use some type of mail gateway. And these are some of the different security protocols. So for video, you have the SRTP, the Secure Real-Time Transport Protocol. Time again, this is not encrypted, but this is hugely, hugely important. This one, DNS, and DHCP are the three hugest services on the network. This time, that's for all our logs, for authentication, encryption. If our times are way out of whack, things don't work correctly. So this is a huge service that you use all the time. And we have remote access, VPN. Again, upgrading DNS from standard DNS to DNSSEC. And then we have, IPsec for our secure connections. And of course, everybody knows what HTTPS is. That's basically the padlock on the web browser. So the book is going to be talking about placing these different technologies. So we've already talked about SSL and TLS in the previous chapter of encryption. Port mirroring, that basically allows us to copy data coming out of one port of a switch into another one, and a network tap. So here are some examples. Here's a thing called T-Shark, which is a tap. Basically, this goes in line. You'd have your say we'd have our switch here, and then here this could be another switch, it could be a PC, it could be whatever. It's just physically in between the cables. So you literally broke this cable, cut the cable in half, put two RJ45s on, put this box in the middle, and then here we would have our PC that would see all the traffic between, let's say this is an uplink between the two switches, it would see all the traffic. And then here, port monitoring, again, this is based on the switch that that supports this feature. So an example here is whatever conversation, if A is having with B, so that conversation would come this way and this way. But it also would copy to this guy here, so D would see it. But if B and C were talking, nobody would hear this conversation, because it's only the person is monitoring A. The network security guy or whoever's doing this monitoring only cares about what's going on with computer A. So again, this is used for security reasons. It's used for network troubleshooting, different things. So now we're going to get into placing these technologies. So here they're showing an example. We want to monitor stuff going out to the internet. So we have port monitoring off of the switch, and then typically we have a computer or some type of capturing device. So like an example, we could have Snort, intrusion detection system running there. It doesn't have to be just a PC running Wireshark. It could be some other advanced software. It could be an IPS or an IDS sitting there. So again, this could be running Snort in a passive mode. So here we're just showing an example of where we're placing it. Maybe we're looking at a particular area of the network. We don't necessarily worry about everything going out to the internet, but we want to, monitor certain functionality. So, and then the book's talking about different sensors, collectors, filters. So again, these are some different locations. So we may want to, and then we're going to send all this data. So basically we have a database server that could be basically collecting all our sensor data, our filters. So again, it depends. So again, you got to think about a couple things. You got to think about, this is right here your north and south. That means anything coming in your network from the internet and out, that's your north and south. And then west and east would be like from here to here. This is probably the hardest to collect and monitor traffic because you have so many different endpoints. Think about it. If you have an organization like our school that has over 500 computers, that's a lot of monitoring between machines. So that's a really tough one. So people tend to monitor certain areas. So like an example, they'll have a sensor here where they're going to monitor, traffic coming in here into the DMZ, and then into our internal server network. We may have another location here, or we may place a firewall here to protect us from our east-west, because again, somebody walks up with a flash, leaves a flash drive, someone plugs it in, now they can go attack us from internally. So our other types of stuff, we have aggregate links. So what that means, if we go back here to this, like an example of this switch, or back up here so we can just draw. So we'd have like a switch here and a second switch here. So we'd have normally one link to link the two switches, but we can aggregate them and make 2, 3. And by doing that, now we've gone to 3 gig. We have gone to 3 gigabytes because that's what we're doing, is we taking 3 pipes, combining them together, and then that gives us the new max speed. So that's a way we can have faster uploads or faster uplinks between 2 switches, is by adding multiple links together, and now we're putting them in parallel. So we don't actually get one 3 gigabyte speed, but now we have 3 lanes of each 1 gig. So we can, in theory, push 3 gigs of data at the same time. So here's the other 2 stuff that's left in this part of the chapter. So we have correlation engine, which basically uncovers attacks apart. This is basically again part of the SIMS from last chapter, where we're looking at all the data and putting it together, correlating the facts. How does this attack happen? And then DOS mitigation. This is some type of hardware that we purchase, or do we work with our ISP to help mitigate these problems? Again, places like this, like online gambling places that tend to do a lot of high traffic, that their downtime is going to cost them millions of dollars. They're going to have some type of DOS mitigation. All right, this is a good stopping point. Catch you in part 2. Bye.